Okay, so here we have another example of an RC response circuit. And the only thing this time we're solving for is we want to find the initial voltage between these two nodes. And to start off, we'll start by redrawing the circuit with the switch closed. So we'll just kind of copy right here and redraw this with the switch closed. Now, we want to remember that when voltage has been going through these capacitors for a long time, they will turn into open circuits. And this is because we want to remember that the equation for the current through capacitor is I equals C dV dt. And when there's no change in voltage, there is no current. So this becomes an open circuit. And we can just redraw the circuit as such with open circuits. Now, what we can do is we need to find the voltage between these two nodes right here. And in order to do that, we can just, since this is just one big loop now, we can just combine all these resistors and find the current. So we can redraw this circuit as such. Boom. Now we can just add up all these resistors, 15 plus 20 plus 40 to get 75K, with this being 15 volts. Now, to get the current, we will just do 15 divided by 75K to get 0.2 milliamps. Okay, now that we know the current, we can get the voltage. So since these resistors are in parallel with these capacitors, we know that the voltage will be the same, because voltage in parallel is the same for devices. So what we'll do is we'll take 20K multiplied by 0.2 milliamps, and that will equal 4 volts. 4 volts, not 4 amps. So now we know that for the 5 milliamp capacitor, there is 4 volts. It is charged with 4 volts. And then we'll do the same thing for the 40K resistor, multiplied by 0.2 milliamps, and we'll get 8 volts for the 1 ohm or 1 farad, microfarad capacitor. Okay, now for the voltage, the initial voltage for the circuit between these two nodes. To do that, we will just simply, first we will remember that the form for the discharge of a capacitor is x of t, initial x of t, e minus t over tau. And the equation for tau for a capacitor is C times R. So next, before we solve for this, we need to find tau for both of these capacitors. And to do that, we will just simply find the circuit. and we'll use pink. So for tau for the 5 microfarad capacitor is going to be 5 microfarads times 20 k ohms. Plugging that into our calculator, we get a tau for the 5 microfarad equal to 0.1. And then for the, over here, tau for the 1 microfarad is going to be equal to 1 microfarad times 40. Okay. So we'll type that into our calculator. 40k, and that's going to be equal to 0.04 seconds. Remember, tau has a unit of seconds. So now we will just, remember, use the form right here. So V of t, initial V of t, for the circuit between those two nodes is going to be for the 5 microfarad capacitor is going to be, we're going to use this value, so it was going to be 4 e minus negative t over 5 microfarad, 0.1 plus 8 e to the power of negative t over 0.04. And that is the equation, or that is the initial voltage between these 2 points after the switch has opened. So when t is greater than 0. Now you'll also see a different form where these are on the top. So that's can be written as 4e minus, and then to move these decimals to the top, we'll do 0.1, the inverse of 0.1, which is 10. So 10t plus 8e to the power of negative, and then we'll move this to the top. We'll take the inverse, 0.04. Inverse of 0.04 is 24, or 25 t. And that is another form that you can see sometimes.